Okay, so for year 11 further maths, we're just recovering Pythagoras Theorem. It's just a bit of revision. Hopefully you've seen this before in year 9 and year 10. The only thing that people may have found difficult in the past is three-dimensional stuff, which we'll cover at the end of the video. So we use Pythagoras Theorem to find an unknown side. So we have to know two sides and we want the third side, and it has to be a right angled triangle. The hypotenuse is always the longest side of a right angled triangle, and sometimes it can be difficult to see which one is the longest side. The longest side will always be opposite the right angle. So if you've got a triangle that's drawn something like this, and it's hard to see what it is, if that's the right angle in there, then this here will be my hypotenuse. For Pythagoras Theorem, we're always going to label the hypotenuse with a C and the other two sides with an A and a B. Which one you call A and B doesn't matter as long as the hypotenuse is C, because then we're going to use Pythagoras Theorem. This particular one up here is Pythagoras Theorem the way it is generally written, but if we take away A squared from both sides, we end up with this rearranged to find B squared, or we can find A squared with it rearranged here. Essentially, if we're looking for a shorter side, it's going to have a takeaway in it with your C squared first. If we're looking for the longer side, it's going to have A plus in it. Examples, find the first 5 of these. We'll do the workings first and then we'll do the answers on the calculator in a moment. So if here's my right angle, there's C, A and B, doesn't matter which one's which. There's the right angle, there's C, so A and B, doesn't matter which one's which. We'll do this one in a moment. So for this, I'm looking for the longest side. So C squared is A squared plus B squared. We don't know what C is, but the letter is X. So X squared is 5 squared plus 12 squared, because A was 5, B was 12. So X squared, 5 squared is 25, 12 squared is 144. So X squared equals 25 plus 144. It's 169. Now, to get rid of the squared from an x, we have to do the opposite. The opposite of a squared is a square root, so we do the square root of both sides. We end up with x equals 13. On this one here, we're looking for a, so we use a formula which is a squared is c squared take b squared. You could use this same formula and rearrange it at the answer, or you can go straight to that formula. Either way is fine. So in this case, a is what we don't know, which is an x, which is c squared is 15 squared take away 10 squared. So x squared, 15 squared is 225, take away 10 squared is 100. So x squared equals 125. Now again, to get the x squared back to just x, find the square root of both sides, and you end up with x equals the square root of 125 is 11.18. With this particular one here, it's a little bit harder because we need to know this side here, but to find this side here, we need to know that side first. So I'm going to do this triangle first of all. With this triangle, I'm looking for C, and there's A and B. So I need to find that one first. So C squared is A squared plus B squared. There is no letter there, so I'm going to keep it as C squared. So C squared equals A was 8 squared plus B was 15 squared. So C squared equals 64 plus 225. Add those two together and you get C squared equals 289. To find out what C is, do the square root of both sides, and you have C equals, I just have to do that on the calculator, and we end up with C equals 17. So from here, I now know this side is 17. Questions in centimeters, which reminds me, if I was marking this, I wouldn't have gave myself full marks here because the answer should have the units. So this is 5 meters. The answer is 13 meters. In that one, 11.18 meters. In this one, at the moment, we're in centimeters. But that's my first triangle. Here I then need to find my second triangle, which in this case we'll do in blue. So we're now looking for this triangle here. There's my right angle, so there's my hypotenuse, that's C. This now is A, and that's B. So C squared equals A squared plus B squared. C in this case is an X. So X squared, A was now the 17. Big hint with this, if this number here is a decimal, when you square this number, it's going to go back to that particular number there to give you a precise answer, which is important in building or something where you have to be exact. Because if something is slightly too small because you're rounding off, then it's not going to fit where it needs to. But we'll make that example show up a bit better later on. And B was 144 squared. 17 squared and 144 squared I'm going to do on a calculator. When I found the two square numbers, I end up with that. I add those two numbers together. Give me 21025. And then to get rid of the squared, find the square root of both sides as well. Which for this was 145, and the question was in centimetres, so my answer should be in centimetres. Good idea, if there's more than one step involved, highlight, underline, put a box around it, do something to make your answer stand out. This now is 3 dimensions, and the important part of 3 dimensions is working out where your triangle is. So I would normally use a highlighter for this, but I'll just fill it in with a line. I'm looking for X. This has to be part of a particular triangle, so I'm looking for this side. That's the one that I'd highlight first. What part of what right angle triangle is that? So we're looking at that, and there's my right angle triangle. If that's 4, because this is a prism, if that's 3, that's also 3, and that's 3. So the triangle that I'm looking for, and a really good idea to draw your diagrams out, has got 4, 3, and X. So then this is my C. A and B doesn't matter which one it is, and C squared is A squared plus B squared. C squared is 3 squared plus 4 squared. C squared, 3 squared is 9, 4 squared is 16. C squared equals 25. Square root of that and square root of that to get rid of the squared, C equals 5. So in this case, it's X equals 5, because that's what C was, and the question was in meters, so the answer is in meters. With the second 3-dimensional one, it's still important to work out where your triangle is. So this side here is one side that I want, so I'm going to highlight that first of all. I have to think, what part of a triangle will that be? So this has to be part of a right angle triangle, but it doesn't show sides there. Now, I could draw a line across the top here, or I could draw a line across the bottom there. Either one will work, whether you want to go upwards or downwards, it does not necessarily matter. But to find this side, we need to make another triangle first, and I'm going to go down the bottom. I'm going to draw a dotted line in, and my first triangle, or my second triangle I'm looking for, will look like that. The problem with this is I don't know this length here. So to find this length here, it's part of another triangle. So this triangle I'm going to do in a different color. I'm going to do this one in blue pen again. And this triangle here across the dotted line. Now again, whether you go that way or you go this way doesn't necessarily matter, as long as you've got a right angle triangle. Because this is a prism, if that side's 3, it means this side's 3, and this side's also 3. This is 5, 5, so that one is 5. So the first one I need to find is this length of this triangle. So with my sides, it's the hypotenuse. So C, A, and B don't necessarily matter. So C squared is A squared plus B squared. C squared equals 3 squared plus 5 squared. C squared is 9 plus 25. So C squared is 34. To find C, square root both sides, and I'll do that on a calculator because it will be a decimal. And I end up finding that this distance here is 5.83. and whatever other decimals are on the calculator, but to 2 decimal places. That's what I've got. Now, for this one, I'm still looking for the hypotenuse, so I'm still looking for C. That now is going to be A, and this side is B. So again, Pythagoras theorem, C squared is A squared plus B squared. C squared is 5.83 squared plus 4 squared. Now, this is where you need to be a little bit careful. If you get a calculator and you put in 5.83 squared and not the whole decimal places that the answer had, your measurement will be slightly off. It will be slightly smaller because you're not including those other parts of the decimal. That can become important if you are building. You don't want something going between here and here to be shorter than what it actually needs to be. So if you square this number, including all the other decimal places, it has to make this 34 that was up there. So instead of doing 5.83 on the calculator, I just know that this number, including the decimals, or you could square the whole number on your calculator, it will take you back to the 34 because the square root of this is that, so that squared has to be 34. And 4 squared is 16, so C squared equals 50. To find C, do the square root of both sides, and we have C equal to, I'll do the square root of 50 on the calculator. We have 0.07 meters. Now, the question had X, so the answer should be X equals 7.07 meters. Again, good idea to make your answer stand out. Look at it, does it make sense? Will you have a length of 7.07 in there? It's within similar measurements. It's not too much bigger, but it is bigger than the 5 and the 4 and the 3, so it does make sense. A common question here could be, what is the longest, say, pencil could fit in a box that is this dimensions? The longest pencil you could have fitting goes from this corner to that corner, and that's when you need your 2 lots of Pythagoras' theorem. Is a triangle with side lengths of 3, 6, and 10 a right angle triangle? Sorry, 6, 8, and 10 a right angle triangle. For a right angle triangle to exist, it means it follows Pythagoras' theorem. So with this, A and B don't matter, but your hypotenuse, your longest side, has to be C, and in this case, the longest number, or the biggest number, is 10. So if that goes into a triangle, if we want to see if it works, C squared is equal to, not plus, A squared plus B squared. So 10 squared is equal to 6 squared plus 8 squared. So 100, 6 squared is 36 plus 64. 100 equals 100. So it does. So the answer that you're looking for is yes. Just on a side note, if you did all this working and say you had 100 equals 42, right, it doesn't equal 42, so this would give you the answer of no. But this one here is what we're looking for. It is a right angle triangle because it fits Pythagoras' theorem.